Now we move on to number 33. Number 33 asks, what is the equation of this line? So we have a line here. We want to put it in slope-intercept form. We could put it in point-slope form, but normally that's a little harder, so I don't want to do that. So I'm going to go ahead and put it in slope-intercept form. So slope-intercept form is y equals mx plus b. Of course, we'll be using that more often. Remember, point-slope form is different. This is slope-intercept form. So that means I need to figure out what my b value is. Remember that b is the y-intercept. Here's the y-intercept, so b is equal to 3. And then my slope is equal to, notice we go from the leftmost point to the rightmost point. So we're going to go 1, 2, 3 down, which is negative. So that would be negative 3 over, and then we go 1, 2, 3, 4 to go to the other side over there. So there's my slope. So y equals negative 3/4 x plus 3. Number 34. Write an equation in slope-intercept form. So now we have to have it in slope-intercept form. So we need to have it in y equals mx plus b. But we're given a point and a slope. So we're going to start off with point-slope form. Okay, so I'm going to plug in the values into here. So y plus 2, because y1 is negative 2, equals 4, because the slope is 4, times x minus, and this time we just leave it as 3. Our next step then would be to distribute. So we have y plus 2 equals 4x minus 12. Solve for y. Y equals 4x minus 14. Okay, 35. So we have a data set that shows us the number of minutes you're on your phone in class versus your grade. So here we have the number of minutes. So 10 minutes, 20 minutes, 30 minutes, all the way up to 70 minutes, and your grade from an F to an A. And notice that the less you use your phone, you can actually look at this data here, and you can see that there are more students who did perform well if they were on their phone for a short amount of time versus those students all the way to the right that were on their phones most of the time and they were failing the class. And you'll notice that the data appears pretty closely to reveal a solid line. And so then what do we get from that solid line? So is there a correlation between the two? Because the data is so tight and we can see that there is some type of line and some type of movement, we know that it's a yes. If so, what type? Well, look at the slope. Is the slope positive, which means it's positive, or is it negative, which means it's negative? So in this case, it would be negative. On another picture here, so we have the amount of time watching TV per month versus getting a heating bill every month. So what it's really asking is, if you sit down and watch TV a lot, are you going to pay more in heating costs? And you'll notice that this part here kind of looks like it's going up. This part looks like it's going down. So it doesn't seem like there's a really good relationship to make a determination if I can put a line there. And the data is so spread apart that I can't really see any kind of trend that's happening in this particular case. So I would say the correlation for this one is a big fat no. Okay, last problem. So in this particular problem now, I'm going to bring it down a little bit more. So in this problem now, we have a graph, and I drew a couple of them and asked a couple of questions about both of them. So first off, looking at the black lined graph, is that a function? So if I were to draw a vertical line here, would it cross only the black lighted or the black picture or graph? Only in that case, we're only looking at that one. Is that a function? Yes, because if we draw a vertical line, it will go through it. What about the blue one? Yes, if I draw a vertical line, it's never going to go through it twice. Okay, so I would say yes on both. So yes and yes. Okay, can we determine, doesn't mean do we have to know the minimum, but can we determine the minimum of this function? So the absolute minimum, yes, we can, because we can see it's going to negative infinity. Can we determine the maximum? Yes, we can see that the maximum value is positive infinity. So I say yes, and we can also determine a minimum. Okay, a y integer. Notice this one crosses here at the y integer. This one crosses here at the y integer. So I would say yes. We know that we can identify that. And then we have two more left. We have zeros and symmetry. Well, this term you probably haven't heard much. I have talked about this term just to make sure that you understand it. And